Okay, please, welcome to Impact Physics. My name is Mr. Darlington, and today we are going to be solving question number 10 EII. Physics Waec 2024 EC 10 EII. So I'm going to read the question so that you can solve along with me. So it reads, use the answer in 10 EI to determine the change in optical power of the normal human eye when reading a book and viewing the sky. Lens to retinal distance is 2.5 cm. Let's go to the board. So now for us to determine the change, first of all, we're asked to use an information in 10 EI. That information will be projected on the screen for you to see. So the information is that the near point of a human eye is about 25 cm. So what is near point? Near point is the closest distance a person can see. A normal person can see objects clearly. That is, a normal human eye can see objects clearly. So far point is the farthest distance, a normal eye can see objects clearly. So let's progress. So change in optical power. It's just talking about the difference between the near point and far point as it relates to this question. And then we are going to do that. So, but you should know that the power of a lens is given as a reciprocal of the focal length. I may not have the opportunity to talk about focal length and everything that has to do with lens, but that can be done later on. And if you do want me to do the video immediately, please comment and let me know, and I will do the video. So let's carry on. So we have this, we have written everything down. The retina to lens distance is actually the image distance. The image is formed on the retina, and the image is a real image because the image can be caught on a screen. Is that okay? And the image that is formed on the retina is actually imparted. So let's carry on. So we have this, we have this, we have this. So for the near point, let's get the near point. The near point, the power for the near point will be 1 over f, and this will be equal to 1 over what is the object distance? We're having about 0.25. Okay, let me just state the equation first. We'll have u plus what? 1 over what? V. So our object distance will be 1 over 0.25 plus what? 1 over v. I'm supposed to substitute for v, but I wouldn't substitute for v, and I'm going to explain when I write the equation for the what? Far point. This will be 1 over f equal to the same formula, 1 over u plus what? 1 over what? V equal to. So now for the farthest distance will be 1 over infinity. The farthest distance, which is the far point of the normal human eye, will be infinity. So now this will be plus 1 over v. Now we know that the value of v and the value of v will be the same. So there will be no need of substituting what? This value, putting this value, plugging in this value for what? For v. There will be no need for that. So let's go ahead and determine the change in optical power. The change in optical power will just be this one, which is 1 over 0.25 plus 1 over v minus 1 over infinity, and then minus 1 over v. So now let's progress. We are going to have 1 over 0.25. Now this will cancel this, and then this will 1 over infinity is actually 0. So we are only having 1 over 0.25. So here we're going to have 1 over 25 will be around 4 diopters. So that's the formula. Sorry, that's the unit for power. So this is the change in the optical what? In the optical power of what? The lens. Is that okay? So thank you very much. Like I said, I do not have a calculator, so I'm trying to improvise. So you don't need to be worried about that. What I'm trying to say is that with time, a lot of things will improve. So this is question number 10 EII. I'm focusing more on the calculation questions because people complain a lot about the calculation questions. So I decided to work on the calculation questions. If you also need responses about the theory questions, or you need reactions, you want me to say something about the questions, the theory questions that don't have anything that has to do with calculation, I will definitely respond to you. Or if there's something you want me to teach you so that you can understand better, there's no problem. So you are expected to follow me on YouTube, Darlington_physics for more. Thank you very much for watching.